Max Planck Society is a big research organization in Germany that runs a whole series of institutes like this one, each specializing in a different field. So we specialize on chemistry and physics, and like the other Max Planck Institutes, we're extremely well equipped with all of the apparatus needed to really do, hopefully, forefront research. We are an institute which specializes in research at the boundaries between physics and chemistry. We have a wonderful set of equipment, the like of which I haven't seen anywhere else, which allows us to address problems, a class of problems which we hope are unique. I work in what's called the physics of quantum materials. What we do is to specialize in looking at very, very pure materials that are sometimes chemically complex. So we work at the interface between the chemistry of developing these new materials and the very high precision science of measuring them.
The mission of our institute is to investigate and design new materials with new properties. This is all about quantum materials, and this is quite unique in the world that we have these two groups of scientists together in one building. My field of research concerns a class of materials of strongly correlated electron systems. These are materials containing rare earth and transition metal elements, and it's characterized by many spectacular properties, but actually it's very complex to describe them because the motion of the electrons are so entangled that it becomes very difficult. So we do a combination of theory and experiment, and the experiments that I do are based mostly on X-ray spectroscopies.
I'm working in the field chemical metal science. The research field is involved with the investigation of intermetallic compounds from the point of view of an inorganic chemist, as these materials form an important part of both functional and constructive materials. We try to understand the bonding and the consequences for the electron count to gain an understanding of these materials. I'm doing synthesis at high pressures, which is a parameter which is less investigated than the common parameters, which are temperature or composition.
In the chemical bonding part of this whole department, we are working again in three parts of a triangle. The main goal is the development of new bonding indicators. As a second step, we have an application part where we have to calibrate our newly developed indicators, and only the final step would then be the full application to actual systems of interest. The whole group is then incorporated in the chemical metal science department in such a way that we have interfaces exactly to the structure group and the synthesis group and the physical properties part of the department.
This institute is a quite magnificent place to work. First of all, we have excellent research facilities, but more important actually is the people that we have. I have 3 other colleagues, co-directors, that are super experts in their field, and there are other staff scientists that are also highly expert in their own research field.
I work in the field of topological semi-methods, and I'm particularly interested in the connection between solid-state physics and high-energy physics, such as cosmology or particle physics. My group specifically collaborates with groups all over the world, for example, Harvard University, Stanford or Berkeley, but also with IBM Research Zurich, for example, or the Weizmann Institute in Israel.
I am a postdoctoral researcher here, and I work on thermal conductivity at low temperatures. I like the research possibilities here in that it is geared towards basic sciences, and we are given the opportunity to explore our curiosities freely.
I'm a final year PhD student, and I'm working on uniaxial strain measurements at low temperatures. The brilliant thing about the research possibilities at the MPI is, firstly, the resources that you have to conduct your research is really quite unique to this institute, and also the colleagues that you have around you to discuss on a day-to-day basis what you're doing.
Collaboration is extremely important to us within the Max Planck Society, and we're lucky that we have a number of Max Planck Institutes elsewhere in the country who do similar work to us. We collaborate very strongly and happily with them. For this institute, I think it's simply put, we aspire to continue to work right at the research forefront and hopefully to do really good work.